Good morning students. I am Vetri Chelvi again from Vetri and Vetri Deep Chemistry Coaching. Today now I am going to give the products of electrolysis of your sodium chloride. The previous video I gave the trick to calculate the products of electrolysis. What is the previous video content is the reduction potential and oxidation potential. In the case of cathode, water is having oxidation reduction potential more than 1 to 13 group mean water will be reduced. In the case of oxidation, that is at anode, water is having more oxidation potential, sulfate mean water will be getting oxidized. So here the comparison of oxidation and reduction potential of the elements which is existing. So the points already I have finished in the previous video. Now let us going to solve this question. What is the product of electrolysis of aqueous sodium chloride, fused to sodium chloride, aqueous copper sulfate with platinum, aqueous copper sulfate with a copper electrode? Now first I am going to give this one. What are the products we are going to get from the aqueous sodium chloride? Now let us here write aqueous, whatever you want to get it, you write at the middle. First, aqueous sodium chloride. Here they are not specific about the electrode, so you need not consider. Now this one you divide into 2. So now this is the column for cathode. Cathode means cation moves to cathode, so minus. What is going on at the cathode is reduction. What is reduction is gain of electrons. Now let us coming to the same thing. Anode, positive charge, oxidation, and it is loss of electrons. Now let us see your cathode cation moves. So when you are doing the electrolysis of aqueous sodium chloride, sodium cation reaches the cathode. Now sodium is there. Along with that, water is also there because it is the aqueous sodium chloride. Now we have to compare the reduction potential of water and sodium. Reduction potential of water is greater than the reduction potential of Na+. So water is reduced. So what is the reaction of reduction of water is? That is your gain of electron. So it gain electron gives reduction of water is hydrogen plus here it is OH minus and balancing. Here it is how much? 2 hydrogen. 2 and here what is it called as a, yes, this one hydrogen will come as a gas. So when water is 2 water, so how much? Yes, here it is 2. So now you are putting the 2 electrons. So this is the reduction reaction of your water. The gas, what is it called? Hydrogen is released at the cathode. This is the first point. In the case of anode, what are the things are there mean? Anion moves to anode mean the anion is your, what is your anion is? Sodium chloride. Ion is to give Na plus and Cl minus. The anion Cl minus is accumulated at anode, along with that water is there because it is aqueous. Now the reduction races between the oxidation potential of water and chlorine. Oxidation potential of your chlorine is greater than water. So it is getting oxidized. So your chlorine oxidized, Cl minus oxidized to chlorine. Oxidation, so it is the loss of electron. You balance the atom and here it is. So this reaction. So finally what you are telling is chlorine gas is liberated at the anode. So now as an answer, so at cathode, you are writing at cathode, hydrogen gas is evolved. At anode, chlorine gas is evolved when you are doing the electrolysis of aqueous sodium chloride. So this is the answer. When you are going to do the next one, fused sodium chloride, that is we can call it as a fused sodium chloride, or it can be given as a solid. Again the electrode is not given, so you need not worry about the electrode. Now it is cation moves to cathode, Na plus, anion moves to anode. Here it is in solid and or we can call it as a fuse. Here it is regular thing is going on. So this cation Na plus follows the type of the reaction is, here it is reduction. Gain of electron gives sodium metal. Here it is. Here what is it? Loss of electron. It gives. Here this is 2 number, 2 electron. So now sodium at cathode and chlorine at anode. This is when you are having the, what is it called, the solid sodium chloride. So these two are the different. Aqueous sodium chloride, hydrogen and chlorine. Solid sodium chloride, sodium at cathode and chlorine at anode. This is one set of the answer. The same way we have to answer for aqueous copper sulfate. The different knowledge is, here it is inert electrode and here it is copper. Now I am going to teach you what happening with the copper sulfate, inert as well as the active. Now let us see the next part. Yes, here it is electrolysis of aqueous copper sulfate. I gave the electrode platinum, it indicates inert. As usual, regular. Here it is, what we are writing is cathode. That is sign. What is going on is reduction. What is it? Gain of electron. So now here what is it? Anode. And what is it? Here it is sign. And here it is going on is oxidation. Now let us hear what is it? Cathode, cation. Copper is here coming and water. Oxidation potential of your copper is greater. Copper is greater here than your water. So what is the reaction is going on? Copper 2 plus 2 electron gives copper. So that is answer. At what is the thing is at cathode, who is copper is reduced. This is the first point. Let us see here anode. So what are the things are here? Anode is SO4 2 minus and water. Here the oxidation potential of water is greater than SO4 2 minus. So water is getting oxidized. So oxidation of water is water. Here oxidized gives 2 molecules of water. Oxygen molecule 4 H plus 4 electron. Now oxygen gas is about. Now here what is the thing is at anode. Now let me write at anode. What are the things are getting here? Oxygen gases evolved. So this is the product for the aqueous copper sulfate. Now let us see the same aqueous copper sulfate with the active electrode. This is the important point. Active electrode. Now let me see. Okay, ma'am. Yes, this one. Same aqueous copper sulfate by here copper. That means active electrode. What is the meaning of active electrode? Mean any metal with inert salt solution is called as an active electrode. Here inert means platinum in copper sulfate. Here copper is in copper sulfate. Zinc in zinc sulfate. Silver in silver sulfate. That is active. Now let us see what is the product. In the case of cathode, same thing. Copper 2 plus water. Reduction potential of copper is greater. Reduction potential of copper is greater. So copper is reduced. 2 plus gives what is reduction. So parallel, please always keep it in the mind. Reduction. So gain of electron. So it gives copper. So what is this? Copper is deposited. Okay, where? At the cathode. This is first point. Second point, here SO4 2 minus as well as the water. But the electrode is active. So what is going on is here the copper, here itself copper getting oxidized. The reaction going on is oxidation. So it oxidizes to give copper 2 plus 2 electron. So what it indicate? The copper dissolves. So what does indicate? Copper dissolves. So I can write as a copper dissolve. That is goes into the solution at anode. So with that we are completing in what way the electrodes are having role with the products. Active mean copper deposited and copper dissolves. Here if it is inert mean at cathode copper is reduced, we can call it as a deposit. whereas at the anode, oxygen is evolved. So with that, I am concluding that electrolysis of this thing depends upon the dilution as well as the nature of the electrode. Thank you, children.